All right. So yeah, so this is our second study group now. So this is where I like to say like the first few study groups, you generally will have like a study group dedicated just to section 1, just to section 2, section 3, and so on. Because these first few study groups are honestly a little more just like, oh, here's the basics. You'll see me kind of jump around a little bit for this week and next week. So technically I might go over some of the stuff that's in other sections like section 2, which you may or may not have gone over yet. But I want to give you guys some of the basic stuff, like for example, navigating to the terminal, using Git, like I did last time. And then I'll talk about some Python stuff too. But one part in there in the section 1 talks about the data science process, right? And saying like, what is it like when you're talking about being a data scientist, right? And so I just want to kind of briefly talk about this because I think it's important to kind of know like, what are we doing? So we're first going to start really like these first few sections are really talking about like, okay, getting the skill set ready so we can do data science stuff. But it's nice to know like, what does this entail? Like, what are we going to end up doing as a data scientist? Okay, so let me go ahead and share my screen. All right, so you guys should see this big old circle with the data science. Cool, awesome. So, all right, so this is kind of like, there's a whole bunch of ways we can talk about this, and especially as you guys get into your first data science project, we'll go into more details of different frameworks like CrispDM and awesome like frameworks on how to do a data science process. But in general, this is where data science is a really interesting field. It's evolving constantly, especially right now. It's relatively young. Like I would say like, not too like, maybe like, I'm trying to think like when the term actually was being used, but data science, like the term has definitely not been around as like maybe like less than 10 years. So it's a really like evolving field exactly what this is. And we basically as data scientists have to do, I would like to say like 3 different major skill sets. The first skill set is basically programming, right? Computer science stuff. You're programming stuff, you're interacting with computers. You have to know how computers work. You have to know how to program things. And this is a big deal because there's a lot of people who can do a lot of the other steps, but maybe not necessarily know how to program things. So that's where it's a big like emphasis where you say, okay, when you know how to program. The other part would be your mathematics skills. In your mathematics skills, basically it's very like, not very wide, but like the main things you need to like know as a data scientist or that are going to help you as a data scientist are statistics, so overall statistics, but also knowing understanding linear algebra and calculus will definitely be helping you along, especially as we go into more predictive modeling steps and machine learning and all that interesting stuff. Now, if you guys on either one of those steps are saying computer science or the mathematics and you're just like, ooh, like that's one of those things like really kind of says like, oh, I really don't know a whole lot about that. The good thing is that you as a data scientist don't have to be perfect, right? There's a lot of things you have to know. And note that basically very few people, if anyone, actually knows how to do these things like perfectly. And so your real goal, like the joke usually is that as a data scientist, you're better at programming than a statistician, but you know more statistics than a programmer. And that's kind of like that crossover you want to be in, because the main idea is that you want to be able to do the things that you need to as the problem arises. And there's a third kind of like skill set that I like to talk about, which some people do like talk about it, but I think it's an easy one to ignore. And it's really your communication skill of like communicating what you've learned from your program, from your statistics, putting that together and bringing it up to usually I'll talk about like stakeholders. And stakeholders could be a business, could be a nonprofit, could be even yourself in some cases if you're basically exploring things for yourself or whatever you're working with. But the main thing is saying, you want to be able to convey this information beyond just saying, oh, we have, this prediction, this is 86% accurate. Well, okay, is that good? Is that bad? Is there improvement? What does it mean? What actionable things do we have? And this is where people talk about the business understanding or domain knowledge. So those of you, for example, I had one of my students was archaeology major, PhD, and she definitely had domain knowledge in archaeology. Now, most people wouldn't think immediately data science in that. But what was really cool is like, for example, I just had her capstone, so that's why I'm pretty excited to talk about her. But she would talk about, for her project was NLP, and she was talking about kind of like the culture of like this her data set and stuff like this of like reviewers on Amazon. And I was just like I was like, hey, like you sound just like an archaeologist right now. And it's really good because you're able to bring that extra domain stuff. So note that you all might have different varying skills and you're bringing different things to the table. And that's what's really cool about data science right now is that there isn't a data scientist profile. It's kind of like there are data scientists and they all have different strengths and weaknesses. And that's where really you're working together, usually as a team as well. Okay, so I want to put that in perspective a little bit of like what a data scientist looks like. Again, the curriculum talks a whole bunch about this too, but I'm sure you can read a bunch of articles talking about like what a data scientist is, and everyone has their own opinion too. It's like what makes a data scientist a data scientist. But back to this diagram that you've been probably staring at for a while now. So this is kind of like the overall framework that I like to say. I like this graphic in general, but basically the main idea is that you start off with essentially this business understanding. You basically start off with some question, something that you want to gain insight about, right? And business understanding, I don't necessarily like using business understanding because it can also be for nonprofits, which might not be really thought of as business. But the main thing is like there's some questions, something that's interesting that you want to ask about, right? So having that in mind is the first step, right? Because without that, you're just basically just doing things for fun, right? Which is perfectly fine, but it's as a data scientist, you want to your job is really to bring insight. So once you understand the problem, what the thing you really care about, then you can kind of move and say, okay, we need to go ahead and get the data, right? And this is where like on this diagram, it says data mining. I usually will talk about this as data acquisition. So data mining, can mean many different things. For example, here it says gather and scrape data necessary for the project, but sometimes data doesn't necessarily have to be web scraped or has to be scraped across another service. Sometimes it's using an API, which we'll talk about later in the future. Basically it's asking a website for information. Web scraping tends to be much more an active role where you're basically going to a website and finding the relevant information automatically, like with your computer and pulling that information. Other times it might already be collected for you. Like maybe that data already exists on the company's server or whatnot. Or maybe you need to combine multiple data sets into one set. And that's really where I would say this data acquisition step, which here's data mining. And then after you get this data, what do you do with it, right? Well, the data are sometimes pretty messy. And what we mean by that, and like you'll hear people talk about this term, and I just love data scientists talking about data. You heard the term dirty data. Has anyone heard that term before already? Kind of give me like a thumbs up, yeah. You'll hear people talk about dirty data, data needs to be cleaned. Sometimes you call it data munging and stuff like this. Basically, data might, like, even though you have all this information, it might not be in the cleanest form that's ready for you to actually process and understand and really gain insights about it. So a lot of times this might be like, maybe, there's misspellings. A really common mistake that sometimes if you get like user input data, is like instead of putting like numbers 1, 2, 3, 4, 5, maybe someone types out the word 1 and actually puts in there. It's like, well, you have to know. It's like, well, like when you're actually cleaning, it's like, well, I want just numerical values. I don't want someone to spell out the number 2 or something like that. So those are things that you have to clean out for. There might be missing values. There might be parts that are mislabeled or mistakes and things like that. A common mistake is that someone does a typo when they're inputting data. They put like 3 twice or something like that. There's also really weird things that happen. Like, for example, someone gives you the data, but it's formatted in a weird way. For example, like, this is pretty common depending on the industry, but you'll get like data sets for like this nice tabular, like things like Excel file. And then inside one of the Excel like cells are things that are separated with like semicolons. And it's like, then you have to kind of pull that stuff out and make sure it's relevant to like what you need to do in like your process. So data cleaning in general, it's a huge step. You will hear people quote, different numbers, exactly how much is. Usually the quote comes between like 70 to 85%, maybe even 90% of your time is done data cleaning and data acquisition, just because there's so many ways the data can just like be not improperly stored, but like stored in a way that you need to basically massage into the right way to make sure you can actually do processes. And we'll see this, especially, I think it's next week is we actually have that section on data cleaning. Okay, so next part, basically, okay, we have our data, we know what we're going to do with it, we cleaned it and everything like that. Next part basically is actually exploring it, seeing what's there. So that's usually like statistical tests, doing plots. We'll talk about data visualization in here, but this is usually what you're seeing, like these really cool looking plots and everything like that. Data exploration basically is learning about what the data looks like and getting a feel for what you're looking for. What patterns do you see already? And this is where you'll hear me talk a lot about visualizations, where as humans, we are very visual, people, our species. Like, we take a lot of things in visually. Like, you'd be surprised how much we can actually take in. And this is where a lot of times, like, doing that visualization can really be helpful. But this can also just be like saying the statistics of, like, oh, what's the mean? What's the median? What's the standard deviation? What's the spread? What's the distribution of the data? That's these kind of steps here. You're basically trying to look for patterns and stuff and see what's interesting and the things that you should proceed forward. The next step that we kind of go from here is this feature engineering. And so this feature engineering basically is prepping it for really the predictive modeling step. Basically, we're trying to say, okay, what are the relevant things that we think are important? So this could also be dependent on what, by the industry or whatever you're talking about. You have to make sure you're aware of the context. So what I mean by this is that maybe there are certain features in your data set that you pull up that are very easy to pull out. Maybe they're very inexpensive to collect. And there might be other elements in that data set that are actually really expensive for the stakeholders to actually collect. And so you want to make sure that that's relevant, whatever your features are using next are relevant and make sense for the problem that you're looking at. So at the same time here, you're kind of looking like, okay, what are good patterns, but also what are things that will be useful in the end? And that's the kind of stuff that, like I say, is the human element of data scientists. It's like, you can't really necessarily automate. I mean, you could try automating some of this stuff, but having that context in here from data exploration to feature engineering, that's the stuff that you're going to spend like I would say, like, that's where you make your money. Like, that's where you're basically getting like, hey, like, I can figure this stuff out. I'm a human and I can reason things out. Like, where are these biases? Can I use this data? Like, what are these kind of things? So anyway, feature engineering basically is prepping, saying, hey, let's go ahead and see, use these things to predict patterns or look at patterns and stuff like this. Okay, cool. Everyone following me so far about all of these steps so far? Any overall questions? Anything going from business understanding to feature engineering? Okay, cool. And one thing I'll say here that I didn't make explicit is that this looks like a nice circle. Like, you see steps 1, 2, 3, 4, 5. I'm gonna give you guys a secret. It's not that clean. Like, there's a lot of times you're jumping back and forth and stuff like this. A lot of time, for example, feature engineering, you start doing feature engineering and you realize, wait a second, this data is not what I expect it to be. And you have to go back to the data cleaning step. Or you do feature engineering, oh, you know what, I need more data for this. You might go all the way back to data mining and stuff like this. You might reach feature engineering and realize that you're asking the wrong questions, that you need to ask something else, and actually go all the way back to business understanding. So there's a whole bunch of like bouncing around and stuff like this. But in general, this is kind of like the overall flow. All right. So now we get to predictive modeling over here. And predictive modeling is I would say, the sexy stuff, like machine learning, all the things that you hear about, like AI. Like, you'll hear people say AI, and for the record, you'll hear people say AI instead of machine learning or something along those lines, usually because they're more on the non-technical side. And so they like to say AI and, like, all this really like, ooh, artificial intelligence. Really what it's about predictive modeling. You're just trying to find patterns and stuff like this. But this could be machine learning. This can be statistical learning. This is when we talk about, there's some really more advanced steps like deep learning and stuff like this too that might make sense. But the main idea is that you're trying to find patterns and predict outcomes. And this is so you can actually use this tool to make those predictions, but also it can really give you a lot of insight of like what the data can do. If the data can't make certain predictions, your model might not work very well, but that doesn't mean it's a useless model. It might mean that you also get to some insights of like saying, what are the relevant features in this stuff? And we'll talk more about this as we get into predictive modeling in a future module. Okay. And then this is where this part labels it data visualization. I would say more like communicating, like your findings, like this kind of like your conclusion, your results, all these things you can talk about your stakeholders. But usually this involves making, instead of exploratory visualizations like down here, you're making explanatory visualizations. So this is a key part of making like distinction of like if you heard, like, who's heard of a machine learning engineer position? Like, you guys have heard machine learning engineer? Okay, this is about where the machine learning engineer would like stop. Like, they wouldn't really do too much of this part. This is where, as a data scientist, sometimes you can even be called like a decision scientist. Like, I actually have a friend who is a data scientist who his official position is decision scientist, because what you're doing is finding all of this stuff from the very beginning all the way to predictive modeling, and then conveying this to someone who might not be really familiar with the nuance of data science. So this is actually a key point that makes a huge amount of value of like you being able to communicate to someone who's going to be carrying out actionable items, like basically saying, okay, what do we do with this information? And so this is your job right here, is to communicate this part. And this is actually really cool because all of the projects that we're going to be doing in the future, including the capstone, will involve this non-technical piece where you're practicing communicating this really, interesting insights to someone who might not know statistics, might only know, like I like to say, you're talking to someone who might only have the high school level mathematics, right? So you can't talk about, you might not be able to talk about standard deviation. You might not be able to talk about, something, we'll talk about this in the future, but like F1 scores or something like that. Or even sometimes even like box plots might be too advanced or like not familiar enough with this person you're talking to. So this is really like a big deal. And I like to emphasize this part because I think it's really easy for us to forget because it's all the really, like I say, the really sexy, hot stuff right here. But this is the stuff that's probably going to be the most value as a data scientist. And then you can see it's a circle because basically you're never done as a data scientist. There's always more you can do. And basically these might lead to new questions or related questions or, revisiting parts to it. And so at any point, all of these things can kind of fold back into the other part and like start over again. So yeah, that's kind of the overall process. And we'll go more into this too as we get closer to a data science project. But yeah, are there any questions about this overall kind of like structure and what this looks like?
Yeah, just one.
Yeah, go ahead.
It kind of seems a little silly, but I guess it makes sense. Is it really that the majority of a data scientist's time goes into data cleaning just because of like the way data is stored or the inconsistencies of like how it's written?
Yeah, it is really like, I will say it depends. That depending what systems are put in place. If you have a very mature company that knows what the data science process is, almost each of these steps might be processed by a separate team. Like you might have data mining completely separate from the people who are doing the data exploration. Data cleaning might actually be more of a process that data engineers are doing. However, I will say is that the thing about data science is that you sometimes don't know exactly what you need from the data to do your job. Sorry if you can hear a plane right now. But the data cleaning part, a lot of times, like you might have your data, like it's like, oh, it's all clean, quote unquote clean. And then you get it and you get to this feature exploration or the data exploration and you realize, oh, I need this part. Or you go to the feature engineering part, you're like, hey, I need this as well. And you have to go back to this data cleaning part. So that's why this can easily take up a huge amount of your time. I sometimes, sometimes you hear people say like 90% of your time. I think that just depends on like what you're doing. If you're pulling pure raw data, that's very possible. But if you're dealing with a data set with a data warehouse, a data lake, in general, it's a little more clean, but you're probably still gonna have to do some cleaning. So that's why it's important to like know that this is a big part of it. There are steps to automate these things too, for especially data cleaning, but they're not perfect because basically to automate something completely, you have to know the context of what this data is. So for example, you're talking about handle missing data or values, which is like, I think this is like the next section. Has anyone gotten to missing values in the curriculum so far? I don't see any thumbs up, so I think not yet. So I think that's like section 3 or section 4, maybe even later. But one big thing about missing values is that why is it missing? Like that's something that is a context that you have to know. For example, do you guys know survey, like confirmation, well, not confirmation bias, but like when you answer, if you take information from a survey and it's an optional survey, it's possible that only the people who really, really care strongly about this certain thing will actually respond. And the people who don't really care might not respond at all. That can be your missing values. And your missing values can actually be representative of a different group. So you have to be very careful of saying, oh, there's missing values, I'm just going to drop them. Or, oh, they're missing values, I'm going to fill them up with these values. Or like with these, replacement values. It might be that your missing values actually are important, an important aspect of your data. And honestly, that's not super obvious exactly how you make that automated. So that's why this can take a lot of time and there's a lot of, not subjectivity, but basically there's a lot of different options you can do and people will take different routes depending on what their goal is for the data. Yeah, is that I kind of went a little bit more and more, Johnny, but hopefully that kind of answered your question.
No, it does make sense. I understand now. Like, yeah, there can be different scenarios, or like you said,
Yeah.
like, in a survey, only people that really care would take it. I guess
Yeah.
those kind of like anomalies can kind of scramble your data a bit.
Yeah, and that's why a lot of this process here, you guys will find what things work really well, and then you'll see like you can get maybe like 90% of the cleaning, but it's that 10% that just takes so long because you're just trying to figure out exactly what to do with it. Okay, cool, awesome. Well, okay, cool. So I wanted to share with that this with you guys. I really like this diagram just because I think it's a very good generic diagram, but you'll see people do similar diagrams, kind of the same process, but the way I'll break this down is basically you have the questions, you're understanding basically what do your stakeholders want, and then saying data acquisition, that might include cleaning right here, and then actually exploring your data, deciding what to do with your data essentially, and then the modeling step, and then the communication steps. So that's kind of like the overall structure of like what this life cycle looks like. Okay, cool.